Another observation I wanted to point out about inverse functions is if it's a simple function with a singular x, the inverse function should always have the exact same stuff but completely opposite. And just one of the patterns I wanted to show you is that an inverse function has the opposite operations in the opposite order. Again, assuming that there's a single x in your function. If it has more, the algebraic nature of that is more complicated and it's not quite as simplistic towards finding the inverse. Just like in the example we did in the last video, it's a little bit harder to invert a function when there's more than one x. And most of the time you can't, it's impossible and it's not invertible to begin with, so why bother? But anyways, like looking at the examples from the first page, f of x and f inverse, we had 4x plus 5 and x minus 5 over 4. But if I pay attention to the order of operations right here, first I would have 4 times the input, because the multiplication comes first. Then I would add 5 in that order. And if I pay attention to the inverse, what would first happen to x would be I'm going to subtract 5 first, and then divide by 4, because of the way I wrote it as a fraction, based on, because there's really an implied parentheses around the top of a fraction. But what I wanted you to notice is it has the exact same stuff, but it's all backwards. Everything about it's backwards. Instead of adding 5, I'm subtracting 5. Instead of multiplying by 4, I'm dividing by 4. And instead, notice that the order is also inverted. And this is kind of another way you can represent an inverse or kind of figure it out without actually having to do any math. If you just sort of invert everything, that will properly cancel it out. And really, that's the same thing that we do when we solve an equation, right? If I have plus 4, I minus 4. And we usually go in the opposite order of the order of operations. I don't know if you ever wondered, well, why when I solve an equation do I do the adding and subtracting first and dividing lastly? But the whole nature of solving an equation is technically inverting it so that I can get the answer. Like say, I have 2x plus 5 is equal to 3. Our goal of solving x is to really apply individual inverses to properly get x. And the reason I bring all this up is because we can use a lot of we already understand how to solve equations. So we already understand the basic idea of inverses. We don't have to relearn everything from scratch. And that's why when, we are taught to invert a function by changing it to y, swapping them, and then solving, that's why that does what it does. Is because we're trying to reverse engineer what's going to happen. And that's exactly the process of solving an equation. Or solving a function or solving an equation involving x and y for y. And looking at one more, if I was paying attention to the order in which I'm doing things here, first thing would be subtracting 3, then squaring, then multiplying by 1/2. And if I do everything in the reverse order, we'll see that the reverse operation in the reverse order, notice that the opposite of multiplying by 1/2 is multiplying by 2, opposite of squaring is square rooting, and the opposite of subtracting 3 is adding 3. What I would end up with is the inverse function that we had before, which is exactly that, right? X times 2 would happen first, then I'm going to square root that, then add 3. It checks out. It's just another way of sort of understanding, verifying that these inverses make sense, and kind of understanding why the order is so important, right? Because the order in which I do things makes a difference based on the transformations. And when I'm inverting it, I have to make sure everything is in the exact reverse order.